Today we're going to be talking about lesson 3.4 on using inverse functions. First thing we want to talk about is some vocabulary. What's an inverse relation and what's an inverse function? So you'll notice that inverse relations flip-flop the x and the y coordinates. So if you look at the original function, so we have the original relation here. You have x is equal to 0, y is equal to -7. 1, x is equal to 1, y is equal to -4, so on and so forth. Well, in an inverse relation, we're flip-flopping the x and the y. So whatever coordinate x was is now the y coordinate, and whatever coordinate y was is now the x coordinate. Now to determine if functions are inverses, what we want to do is look at the compositions. So if I have f of x, some function f of x, and I have some function g of x, to determine if the relations, inverse functions of each other, do a composition substituting f of g of x and g of f of x, and if the problem simplifies down to equaling just x, then you'll know that these are functions. We don't really refer to g of x as an inverse function in the g of x form. If it turns out to be an inverse function of f of x, we call it the f inverse of x. Alright, so let's take a look at how we go through this process. Example 1. We want to determine if these functions are inverses of each other. Are these inverse functions? So I have f of x, which is equal to 4x plus 3, and I have f inverse of x, which is 1/4 x minus 3/4. First thing we're going to do is verify if f of f inverse x is equal to x. That's going to be the question. So, we're going to replace x with 1/4 x minus 3/4. So take out the x and plug in 1/4 x minus 3/4 plus 3. Let's simplify this. So distribute the 4. 4 times 1/4 x would be 4 over 4x, which is 1x. 4 times negative 3/4 would be -3. And then we have the plus 3 at the back. Continue to simplify. -3 plus 3, they cancel out. So you are left with just 1x. Okay, so far so good. Let's take a look if the opposite is true. Is f inverse of x equal to x when I substitute in the function f of x? So, we are going to substitute in 4x plus 3. So 1/4 times 4x plus 3 minus 3/4. Distribute the 1/4. So 1/4 times 4 would be 1x. And then 1/4 times 3 would be 3/4. And then minus 3/4 back here at the end. Plus 3/4 minus 3/4 simplifies to just x. So since f of inverse x, f inverse of x, simplifies to just x, and f inverse of f of x simplifies to just x, then these are inverse functions. Alright, let's take a look at our next example. Solving word problems. Well, mouse does not want to cooperate with me. There. You earn $8 per hour plus 20 cents for each unit X you produce per hour. The linear model for your hourly wage, W, in terms of X units produced is W is equal to A plus 2/10 X. Find the inverse of the model, then use the inverse function to find the number of units required per hour for your hourly wage to be $12. So right now, our function is telling us that if I know how many units I produce, I can figure out what my hourly wage is. Well, if I rewrite this equation, if I know my hourly wage, I can work backwards to figure out how many units I produced. So let's rewrite this function. All I'm doing is rewriting it in terms of X. So instead of W being by itself, X is going to be by itself. Now 2/10 is the same thing as 1/5. So I'm going to go ahead and multiply both sides by 5 to basically cancel out the 2/10 times 5 would equal 1, so get X by itself here. And then 5W minus 40. So now I have my function in terms of X. If my hourly wage is $12, substitute in 12, and then solve the equation. So 60 minus 40 would give us 20. So that means in order to make $12, I need to produce 20 units of this object, whatever this object is. All right, let's take a look at our next example. All right, finding the inverse of a cubic function. So if I have a function, f of x, and I want to know if the inverse would be a function, I have to do something called the horizontal line test. In algebra, you learned about the vertical line test, where to tell if something is a function, you hold your pencil straight up in front of you, vertically. Vertically, of course, goes this direction. Let's try this with a pen. Vertically goes this way. And so as you go across the x-axis, you want to make sure that your pencil only intercepts one point at a time. Well, to check for the inverse function to be a function, hold your pencil in front of you horizontally and then draw it down the y-axis. Does it only cross one point at a time? Notice how it's only crossing the one point. So since I can do the horizontal line test and my pencil only intersects one point at a time, I know that the inverse will also be a function. So let's find what that function is. Step 1, write the function. Replace f of x with the letter y. So we're taking it out of the function notation for just a moment. And then to find the inverse, we're going to switch places with the x and the y. Now to get it into function notation, remember our ultimate goal is to be the f inverse of x, we need to rewrite this getting y by itself. So solve the equation for terms of y. So add 2 to both sides. Divide by -1. Move this over here for a second. So we have -x minus 2 is equal to y cubed. Take the cube root. So now we have y by itself, and it's equal to the cube root of -x minus 2. And then we rewrite this in function notation. So we have f inverse of x is equal to the cube root of -x minus 2. So that is the function of the original, that's the function of the inverse of the cubic function. What does this look like for a power? So some other exponent. We're going to go through the same process. where we replace f of x with y. And in fact, I'm going to replace that 2/10 with the fraction 1/5. I like dealing with the rational fractions. It makes it a little easier to look at. To write the inverse, we need to switch places. And we want to get y by itself. So, putting everything in terms of y, we're going to first divide by 17. That gives me y to the 1/5. I want to get y by itself. So if I take y to the 1/5 to the 5th power, 1/5 times 5 would be 1. And then of course on this side, I need to take things to the 5th power. And we want to write this in function notation. We could simplify this further, I suppose, if we wanted to say x to the 5th over 17 to the 5th and whatever crazy big number 17 to the 5th is. But since most of our x values are going to be small numbers, we'd rather do the division of 17 first and then take that to the 5th degree first. So this is simple enough. We'll go ahead and keep it like that. And that's it. When we want to find the inverse function, write the original function, flip-flop the x and y, solve for y to get it by itself again. That's your inverse function. Let's take a look at some practice problems. You're going to need to pause this because there's a lot going on here. Read through these 6 questions carefully. And when you're ready to move on, go ahead and press play, and you'll see the answers. All right, so here are the answers to those 6 practice problems. I believe there are no mistakes. If there are, we'll go over them in class. Have questions, circle them. Again, let's talk about it in class.